Example 4, use factored form to graph a quadratic function. How can we use the function f of x to graph? All right, so it looks like we have a standard form function, and if we can take that function and factor it, so here is our factored form again, then we want to do that because that's going to help us graph, and we'll see why in just a second. Now, we first just want to make sure that we have everything on the same side of the function, kind of like in our past examples. If we were not set equal to 0 or just set equal to y, then we'd have to move everything to the same side. But right now we're good to go, so here's what I'm going to do. I'm just going to get rid of the f of x and set our equation, our function, equal to 0. And now we are ready to factor. So I'm going to go ahead and get our factored form all set up. And since our a value is 1, we should be able to find two numbers that multiply to c, but also add to our b value. So c is -8 and b is -2. Two numbers that multiply to -8 and add to -2. Go ahead and pause the video really quick and try to think of those two factors. All right, let's come back together. It's looking like it's going to be some combination of 4 and 2. Now, we need this to multiply to a -8, so one of them has to be negative. But in order to get those values to also add to -2, it's going to have to be -4 and +2. Let's go ahead and plug in those factors where they belong. Doesn't matter which one goes where. And now this is where we can use our zero product property. Take both of our factors, set them equal to 0. When we do that and we solve, we're going to end up getting x equals +4 and x equals -2. So those right there are our x-intercepts, and those are points on our graph that we can use to find the shape of our parabola. So if those are x-intercepts, that means that's where our u-shape crosses the x-axis. I'm going to go ahead and plot those on our graph at +4 and -2. Now it's still a bit tough to see the shape of our u-shape, so we need at least one other point. And what is one other thing that standard form offers us? The y-intercept. Every single time the c value is our y-intercept. That's where we cross the y-axis. So let's head to our y-axis this time. Let's find -8, and we can plot our third point there. Now, to make this graph even more accurate, we could also go through and find the vertex using -b/2a, getting the x value, plugging that back in to find y. But for right now, I think that this is a perfect start. Let's go ahead and draw the shape of our parabola. That u-shape, the y-intercept kind of looks like it's close to the vertex, but it's not exact. The vertex is what makes our u-shape symmetrical. So it'll look something like that, using our x and y intercepts from factored form. All right, let's try one more. The next one says use factoring to graph this function here. Well, I noticed that this is similar to our last function. Everything's on the same side of the equals sign. I think the only difference is this right here. I'm going to highlight it. Our a value. The a value is not 1 like it was before. And if our a value is not 1, we have to use either box method or grouping. I'm going to use grouping this time. You're more than welcome to use factoring. And our goal is still to get to this point here. We want to factor so that we can use our zero product property to solve. All right, to use box method, we start with our a and c values, and we plug the first entire term and the last entire term right into our box where they belong, top left, bottom right. Then we are on a mission to find two numbers that multiply to AC and add to B. So AC would be those two terms that are already in our box, multiply those, which is -6x squared. And our B value is +5x. So for sure, these factors that we find are going to have an x on the end. And we're really just looking for two numbers now that multiply to -6 and add to +5. Let's see, I'm thinking of the numbers 2 and 3. I'm also thinking of 6 and 1. I'm thinking it's going to have to be 6 and 1 somehow. To get that to multiply to a -6 but add to a +5, looks like the 1 is going to have to be negative. So let's test that out. Those do multiply to -6, and they do add to +5. There's our factors. So we go ahead and plug those in our box. Does not matter which one goes where. And now we're ready to factor out our GCFs. I'm going to start here. Actually, let's start here. Doesn't really matter where you start, but I'm going to start here because I saw my factors right away. Between 6 and 3, I can factor out a 3. And my neighbor is positive, so my factor is positive as well. All right, next one, factor out our GCFs. And I can for sure take out an x. And I can only take out 1, so just 1x for that. All right, now we're going to move to our rows. Let me come up with a different color here. Let's do brown. I'm going to factor out those GCFs. We could definitely take out a 2 and an x from both of those. My neighbor is still positive, so that's why these factors are positive. And last but not least, our last row, 1 and 3, we can only really factor out a 1. Can't take out any variables. But my neighbor is negative, so our factor should be a -1. And just like that, guys, we're almost done. Here's our factors. Oh, looks like my x disappeared. There we go. All right, now we can go ahead and rewrite these in our official factored form. We have 2x minus 1 and 1x plus 3. We're going to set those equal to 0, and that means that now we can use our zero product property to solve. So we're going to take each of those factors, set them equal to 0, and solve for our two x-intercepts. For the second one, we're going to get x equals -3. And this first one, we have a little bit more solving to do. And it looks like we get x equals 1/2. All right, we have our x-intercepts. Let's go ahead and head to our x-axis and plot those points. -3 and 1/2. All right. And since this has a positive a value, we should have some upwards U shape. But how do we make this a little bit more accurate? Last thing we're going to do is steal our y-intercept. So where we cross the y-axis is at -3. We could make this more accurate. Like we said before, we'll probably practice this more in class, but finding our vertex also will make this more accurate. But if we go ahead and sketch a graph of what this is going to look like, it's going to be a pretty narrow U shape, as we can see from the first x-intercept and y-intercept. It's going to look something like that. Not perfect, but this is essentially how we can use our factored form to find x and y-intercepts on our parabola.